my thing till I'm out on top. No doubt.
Hello everyone. So today we're going to pretty much build the distance LED meter, or the ultrasonic breadboard project that I have on my YouTube shorts, or even if you've seen this on Reddit or any other page. Welcome. So today, before I get into the project, I'm going to explain some of the components. So we got 7 5mm light LEDs. You can use pretty much any sort of color, just ensure that you have a proper current limiting resistor. Today we're also going to be using an Arduino Uno 4. Arduino R3 suffices for this project, or even a Nano or a Mega, or even an ESP32. Today the main focus, we're going to be using this sensor right here, the HC-SR04, my bad. This sensor essentially has a transmitter and a receiver. And you can see right here, VCC, trig, echo, and ground. So really, just a little backstory of the science of this sensor. Essentially, the transmitter will transmit some ultrasonic waves, which is not visible to the naked eye. Essentially, what it does is when those ultrasonic waves hit an object and bounces back, it is collected and captured by this receiver right here. And essentially what we could do with that data is, well, we can use it to calculate the distance in either centimeters, inches, or really whatever unit that you're interested in. Just really just kind of depend on the mathematics and the code at that point. Some other similar sensors, not sharing the same science, but at least the same the concept behind it. This IR sensor, which is the IR08H, kind of get these online as well as my website in case you're interested in any of these. But this sensor, what it does, it's kind of the same as this. It detects an object and it'll kind of activate. It'll use the other little receiver right there to kind of detect that object and relay it back to this. You can see some potentiometers right here to kind of determine the sensitivity, but we'll use this on another video, kind of just more focus on the ultrasonic sensor for this one. So before we really get into this, we do have this schematic, which I'm going to play right here. We can see that we're using 7 LEDs. The way it works here, it goes from right to left, and we will be using, kind of controlling and making those LEDs a meter using that ultrasonic sensor. So now getting into the build, I kind of already pre-laid out my board here with the 7 current limiting resistors. It's okay to use anywhere from 150 ohms. I'm using 750 ohms just because these are some really bright lights. The way my breadboard is set up, I had to actually combine pretty much the 5-volt or the power rail from one end to this end, because this isn't much of an ordinary breadboard. It is, but it's just the variations. As you can see, it's split in half, as you can see based off of this little blankness right here. So pretty much you do need to connect these two sides to make it one full power rail. So that's what we've done here ahead of time. I'm going to go ahead and grab my ultrasonic sensor, place the VCC and ground according to where they're supposed to go. I'm going to go ahead and grab our LEDs here and begin, at least from left to right, because it might be a little bit more easier. I'm going to begin the build. It shouldn't take too long. Make sure you're cautious of the placement of these resistors and really the LEDs, because one little or minor mistake can lead to a whole burnout, and that's something we don't want here. But this is also not the best quality breadboard, as it's a little bit difficult to just pop these all in here. I believe so. Apologies. Here is 7. So now that we have 7 LEDs now all hooked up, we can go ahead and actually hook these on up to our Arduino. We'll go ahead and SD2, or before I get into that, even though kind of going back to the schematic, we're going to go ahead and actually use digital pins 2 to 8. And really, some of these what we're going to be doing is kind of controlling the dimness of all these LEDs. But we'll get into that once we flash the code. Let's go ahead and just do all this. Okay, now that we have that done, we're going to go ahead and actually connect our trig pin, which is this pin right here, which is quite still visible. We are going to go ahead and connect our trig on over to digital pin 9. And we're going to make sure that echo is connected to digital pin 10. Alright, so we're going to explore the entire program for the distance LED meter. So first we do have the distance meter class. So this class encapsulates everything that's pretty much needed to measure distance and control the LED smoothly. The trig pin, echo pin, so these store the pins that are pretty much connected to the sensor. The LED pins, it's an array that's storing the pins of our LEDs. The num LEDs tells the class how many LEDs we have. And then the max distance is a float, 1 centimeters, so it defines the maximum distance to display on the LEDs. And then we have a constructor, so it takes the pins for the sensor and the LEDs, the number of LEDs, and the maximum distance. It sets the trig pin as an output, and the echo pin as an input, and it initializes all of our LEDs to off. Pretty much using the analog right. So down here we also have the read distance, or the distance reading function. So this pretty much reads it in centimeters. It'll send a short high pulse on the trigger pin, then it reads the duration of the echo signal. So the distance is calculated using the speed of the sound formula, which we have the distance equals duration, and essentially this highlighted equation. And then any invalid reading, like 0 or above max distance, or it's clamped to the max distance centimeters right here. And then we have the LED or update function. So it pretty much handles the LEDs smoothly based on the distance. So it'll read the current distance and it calculates how many LEDs should light up proportionally. And it'll use like a smoother transition. So before the LEDs are fully on, the next LED is partially lit using some PWM signals, and the rest are off. And this creates a visually appealing right or left kind of like bar meter effect. And then a little down here we have the main sketch. So all the LEDs are defined, the physical pins connected from right to left. We have a distance meter object, so with the sensor pins, LED array, LED count, and the max distance, so in this case it's 25 centimeters. And it starts serial communication at 9600 baud rate. And we can see here that we have a small 10 millisecond delay, and that could be always edited. Now that we have flashed the code onto our Arduino here, it's time to connect really the last thing, and that's the power rail. I'm going to go ahead and connect this on over to the 5 volt. We should see some of these LEDs light up right now. Briefly. Okay, nice. So what I'm going to go ahead and do to demonstrate, I'm going to go ahead and use this protoboard PCB to act as our object. Now, as I approach the ultrasonic, we will see those LEDs light up as the object gets closer, and as I get further, those LEDs dim out. So if you've learned something in this video, please feel free definitely to subscribe and like for some more breadboard projects. If you would like to see more videos like this, please give me kind of any recommendations. I do have mass amounts of sensors and really a lot of breadboards and such. But I will catch you in the next video, and thank you so much for watching. Goodbye, everybody.